All right, problem 3 first. It says that segments CF, BD, and AG are all medians. And right here is where those 3 medians are intersecting. What do we call the point where those 3 medians intersect? The centroid. This is the centroid. Yes. Circumcenter is where the 3 perpendicular bisectors intersect. So we have 4 points of concurrency, and we can go look at a problem that looks at all 4 of those if you want to after we go through number 7 and number 11. But there are 4 special centers that you need to know for this test, and you do need to know them by name and which lines they go with. So medians intersect in the centroid, and medians go from a vertex to a what? What would we call these points F, G, and D? Midpoints. And what do midpoints do to sides of triangles? Cuts them in half. So I know that BF is the same size as AF. AD is the same size as DC. And CG is the same size as BG. Now when we have the medians, this is where we did the 1x, 2x, 3x thing. How do I decide where just the x goes versus the 2x? Smaller segment, yes. So it has to go from the centroid to a midpoint. That would be an x. Centroid to a vertex, like right here, that would be a 2x. Would this be an x or a 2x? That would be an x. What about here? That would be a 2x. What about here? That'd be a 2x, yes. And so then this last piece right here, that would be an x. Remember, if it goes to a midpoint, it's an x. If it goes to a corner, then it's a 2x. All right, so part B says that EC is 20. Well, EC is this right here. Is that a 1x, a 2x, or a 3x? That's a 2x. So 2x equals 20. If 2x equals 20, then how big is just x? 10. X is 10. So how big is EF here? That is x, and we just said that x is 10. So this would be 10. What about this? How many x's is this? That's 3x, and so it would be how big? 30.
Isn't this like exactly like the, oh, this makes so much more sense.
Like the homework that we did?
No, yeah, but also the, I had that skills check.
Yep, there was a question on the skills check just like this, yes.
I'm pretty sure this was the same answer.
All right, let's look at this next one. It says AG, this right here, is 21. How many x's is that? 3 x's. I have 2x on one side and x on the other, so that's a 3x. So 3x equals 21. If I divide both sides by 3, that means x is how big? X is 7. It doesn't always go in the 2x place. You got to look at the segment that they've given you and determine whether it is a 1x, a 2x, or a 3x. If it's the whole median from corner to midpoint, then it's a 3x. They ask me now for AE right here. How many x's is that? That's 2 x's. And we said that x is 7. So how big is that segment? 14. Well, how big is this segment here? 7. EG is the segment that is just x big, so that is 7. All right, now it says ED is 8. Well, here's ED. Is that a 1x, a 2x, or a 3x? ED. Is that a 1x, a 2x, or 3x? It's just x. So that means x is 8 here. BD is this. Is that a 1x, a 2x, or a 3x? That's a 3x. And we said that x is 8, so 3 times 8 would give me 24, yes. BE is this segment right here. Is that a 1x, a 2x, or a 3x? 2x. 2x, and x is 8, so 2 times 8 would give me 16, yes. All right, last part, part E. It says that AF is equal to 3x plus 7. That's this right here. 3x plus 7. And that AB, from here all the way over, is 19. Is AF, this right here, the same size as AB? AF and AB.
No.
Yeah, AF and AB are not the same size, so I'm not going to set them equal. AF and FB are. So how many segments this big fit inside this whole thing? 2 of them. So if I do 2 times AF, that gives me the length of segment AB. So if I do 2 times 3x plus 7, that will be equal to 19. I'm going to take this 2 and distribute it. Make sure to multiply both pieces. This is something that I'm seeing happen more and more. When we're distributing on these problems, we're remembering to multiply the first part, but we're forgetting to multiply the second part. So we're multiplying by the 3, but we're forgetting to multiply by the 7. So that would give me 6x plus 14 equals 19. And then what do I do now? Subtract the 14 from both sides. What is 19 minus 14? 5. So I have 6x equals 5. Divide both sides by 6. Does 6 go evenly into 5? Nope. Then I can just leave that as 5 over 6. You said it's 0.8 what? 8.3 repeating? Does the 8 repeat or just the 3? Just the 3. So you could also write it like this. I would accept either one of those as a fully correct answer. All right. Number 7 was the other one that you asked for? Okay. Let's go look at number 7. All right. Where did it go? Here we go. Number 7, can the side lengths on the picture actually make a triangle. So when you look at this, what we're asking is the sum of the two smallest sides greater than the biggest side. That's how we decide whether or not it can make a triangle. So what is the biggest side on this triangle? Which one? 3.9, thank you. There's the biggest side. So the two smallest sides would be 2 and 2.3. So we're going to add 2 and 2.3. What do you get when you add 2 and 2.3? You get 4.3. Oops, not 4.5, 4.3. Is 4.3 greater than 3.9? Yes. So can these make a triangle? Yes. Yes. These side lengths can make a triangle. You just add the two smallest ones together. If that gives you a bigger number than the third side, then it can make a triangle. If it doesn't give you a number that's bigger than the third side, then it can't make a triangle. So let me see if I can give a demonstration as to what's going on here. So if I had sides like this, these were the sides of my triangle. These two sides, when I put them together, aren't bigger than my third side. And when I try to make a triangle out of it, I can't do it. No matter how I move this, I can never make it make a triangle. But now, let's see, now these are still my two smallest sides. When I put the two smallest sides together, it's bigger than my third side, and that means that I can make a triangle out of it. So that's what's going on with that. That's why we add the two smallest sides together. If that third side is too big, I can't make a triangle. Part B, it says list the angles of the triangle ordered from least to greatest. So if I'm going to find the angle that is the least, I need to start by identifying the side that is the least. Which side is the least side? RS2, yes. Here's the smallest side. The smallest side will be opposite the smallest angle. So what is the angle that is opposite my smallest side? T. Right here is my smallest angle. So I would start my list with angle T. Let's go do greatest next, and then we'll fill in the middle. To find the greatest angle, I need the greatest side. Which side is the greatest side? RT is 3.9. We said that that was the biggest side. So S is my biggest angle, yes. So least is T, greatest is S. So what would have to go in the middle then? R has to go in the middle. Do you guys want to go and look at a problem where we talk about the different segments in a triangle and then what we call that special center? Yeah. Okay, let's go look at number 4 then. Let's go look at problem number 4. And if you guys want to see pictures of this, we can look at that also. Absolutely. We should have time. All right. Number 4. The blank of a triangle is where the 3 angle bisectors of a triangle intersect, and it is equidistant from each blank of the triangle. Does anybody remember what we call it where the 3 angle bisectors come together and touch each other? Starts with a vowel. And sometimes Y. This is called the incenter. That's the incenter. And it is equidistant from each side of the triangle. Yasmin, you answered this one earlier. What do we call it where the 3 perpendicular bisectors intersect? Circumcenter. What'd you say? I mean, you have to know the different segments and the names of the centers, yes. So flashcards tonight might be a good idea. The circumcenter is equidistant from each vertex of the triangle. The 3 altitudes intersect in a special center that we call the orthocenter. We did. Very briefly. That's the one that we talked about the least. We talked about that one very, very briefly. And what do we call it where the 3 medians intersect? They touch midpoints, but that's not what we call the special center. Centroid. And the centroid is the center of mass. This is the balance point. I need you to turn it off, please. Centroid is the center of mass, or the balance point. If you find the centroid of a triangle, you can balance it on the tip of a pen. The perfect balance point. Do you guys want to see pictures of what this looks like? Okay. So we're going to be flipping back and forth between this one and the very back page, number 14. So we'll go look at the pictures. We'll decide what we're looking at. Are we looking at angle bisectors, perpendicular bisectors, altitudes, or medians? That's the first thing that we're going to answer. And then we'll say what we call the point of concurrency. What do we call it where all of those come together and touch each other? All right, so flipping back here. I notice these markings right here. What do we use those markings to show? Congruence. Well, it's saying that this segment right here is congruent to this segment right here. So what do I call this point? What do I call that point right there? A midpoint, yes. What do I call this point? That's also a midpoint. It's okay. And what about this point right here? Also a midpoint. What do we call segments that go from a point, a vertex on the triangle, to the midpoint? Vertex to a midpoint. Vertex to a midpoint. Centroid is what we call where they're all intersecting right here. You're right. Median. Each of these is called a median. So the segments that are drawn are the medians. And the point of concurrency is the centroid. Medians go from a vertex to a midpoint. All right. Second one down. I see these congruence markings again. So what do we call these 3 points? Those are midpoints, yes. And you're on the right path. You're just a little bit ahead of me with what you said next. This is a midpoint. And this is a midpoint. What do midpoints do to sides of triangles? Cuts them in half, right? What do we call things that cut something else in half? Starts with a B. Bisector. There's something else that I notice here. And Yasmin, what are you saying? Perpendicular bisectors. They make right angles. And another word that talks about where right angles happen is perpendicular. My perpendicular lines make right angles. So these are perpendicular bisectors. So perpendicular means that it makes 90-degree angles. Bisector means that it touches the midpoint. And what do we call the point of concurrency where those 3 perpendicular bisectors come together? What'd you say? Not the centroid. That was where my medians intersected. But it does start with a C. Go back and look at number 4 if you need to. Circumcenter, yes. The point of concurrency is the circumcenter. So far, so good? So both medians and perpendicular bisectors touch at the midpoint. The way I tell the difference is perpendicular bisectors also have to make right angles there. Do you see anything about congruent segments here? So I don't see any midpoints. Any right angles? You see congruent angles here. What's happening to each of those big angles? They're being cut in half, yes. What do we call things that cut something else in half? Bisector. What is it that's being cut in half here? Yes, these are angle bisectors. And what do we call the point right here where the angle bisectors intersect each other? Go back and look at number 4 if you need to. Close. Where the 3 angle bisectors intersect. Look again. The in-center. In-center and angle bisectors go together. Down here on this last one, are there any midpoints? We've got 90s, 90-degree angles. Are they touching at the exact center point of those sides? No. What do we call the segments that go from a vertex to the opposite side and they make a right angle when they get there? Starts at a vertex, goes to the opposite side, and when it hits the opposite side, it makes a right angle. Starts with an A. Look back at number 4. Starts with a vowel. Starts with an A. Altitudes. These are the altitudes. Altitudes go from a vertex, and they are perpendicular to the opposite side. What do we call this point of concurrency of the three altitudes? Orthocenter. Beautiful. Beautiful, beautiful. You do need to know what these three types of segments look like when they're drawn in. You need to know which ones hit midpoints, which ones make right angles. You need to know what we call it, where those three lines of that type are intersecting. So maybe make some flashcards. This is a great one. If you don't want to make actual flashcards, cover up the answers and see if you can identify them again. All right. Number 9 was the next one that I was asked for. You still with me, dear? All right, let's go do number 9 now. Number 9 says we want to find a range of possible values for x. How many triangles are there in the picture? 2 triangles. Well, when I want to find a range of possible values, and I have 2 triangles, I have to try to use the hinge theorem. Hinge theorem means I have to have 2 pairs of congruent sides. Do I have 2 pairs of congruent sides here? Yes. We have this side that's 32 and this side that's 32. And then we have the shared side right in the middle. Once I have identified my 2 pairs of congruent sides, then we're going to find the included angle. Put that away. In between my 2 marked sides is going to be my included angle. So this is one included angle. And these 2 marked sides, in between there is this included angle. Now, if you remember when we did this, we know we're going to have an inequality. Smallest thing farthest on the left. X goes in the middle. Biggest thing over to the right. Just like a number line, smallest on the left, biggest on the right. All right, so I'm going to grab the thing that has x, 2x plus 6, goes right in the center. Bring down those inequalities. Is 2x plus 6 a side or an angle? 2x plus 6 is an angle. So on either side, I'm going to have angle things because they're either all angles or they're all sides. We never mix sides and angles together. So I need to know whether 34 goes over here or over here. So I need to know if 34 is bigger or smaller. I heard smaller. Why is it smaller? Because it's across from the 20. This is my smaller side. So that means 34 degrees is my smaller included angle. So I have 34 degrees over here. And now, do I have an angle to put on the biggest side? Like, is there an angle in the picture that I would put on the biggest side? No. I have the thing with x that always goes in the middle, and the other object that is the same type of object as where x is, in this case 2 angles. That other angle will either be smaller or bigger. It's going to go on one side or the other. But then I've got one side that I got to figure out. All angles in a triangle have to be smaller than what? Has to be smaller than 180. because the three angles in a triangle all add up to be 180. So if I had one angle all by itself that was already 180, I couldn't add two more things to it and still have 180. Why couldn't 0 be the biggest? Because 0 is not bigger than 34. Why couldn't it be X'd out? Because angles have an upper limit. Angles can't be bigger than 180. You always have a lower limit, that's 0. Angles have an upper limit of 180. Sides don't have an upper limit. So I have to pay attention to whether X is part of an angle or whether X is part of a side. Because if it's part of a side, there's no upper limit. All right, drawing my fences. We want to get X all by itself, so I'm looking in the middle here. What would I need to do in the center here to get X all by itself? Subtract 6 from both sides, or from all sides rather. Minus 6, minus 6, cross the 6 out in the center. Okay. Okay, thank you. What do I still have in the center? 2x. Bring down the inequalities. What do we have on the left? 28. What do we have on the right? 174. 174. And then what do? Divide everybody by 2 so that we can get X alone in the middle. Bring down those inequalities. What is 28 divided by 2? 14. And 174 divided by 2? 87. So X is in between 14 and 87. So X could be 20, but X couldn't be 0. X couldn't be 100. Right. Let's go do part B on this. Part B is a similar problem, except when you look at part B, where's X? It's on a side. So I'm going to put this down. Can I use the hinge theorem here? Tell me why. Yep, I've got these sides that are marked as congruent, and then where's my other side? The shared side, yes. Here's an included angle. And here's an included angle. X is part of a side, 7x minus 6. So that goes in the center with my less thans on either side. 48 is bigger. Tell me why. 41 is bigger than 22, so 48 is my bigger third side. Because 41 is my bigger included angle. Remember, whatever X is, if X is part of a side, then the other numbers that I put up here have to come from sides. They can't come from angles. If X is part of an angle, then the other numbers up here have to be from angles. Because it all has to be the same type of thing. All right, we said that that's the bigger third side. Where do I put bigger things?
On the bigger side.
On the bigger side. So that's where 48 goes. Well, all sides have to be bigger than what? 0. So whenever I don't know a smallest, I always fill it in with a 0. Angles have to be bigger than 0. Sides have to be bigger than 0. Let's draw in our fences. First thing I do, add 6. We're going to add 6 in the middle and then on both sides. Cancels out in the center. What do I have remaining in the center? 7x. Bring down those inequalities. Yep, I have 6 on the left and 54 on the right. Now what do I do? Divide everybody by 7. Does 7 go evenly into 6? No. So I can leave that written as 6 over 7. Or I can change it into its decimal form. It's 0.857 or 0.86. Does 7 go evenly into 54? No. So I can leave that written as 54 over 7, or I can change it into its decimal form, which is about 7.714. Decimal form or fraction form is perfectly fine. If there's a really short one, I can go over a short one, but that's all I have time left for. Does anybody have one that they think would be short? I don't know. Let's look. Yeah, 10 actually is really fast. That's a perfect one for us to end on. Hannah, Priya, and Kenny sit next to each other at school, forming a triangular work area. The possible range for the distance between Hannah and Priya is... So we have our lower boundary down here. Yep, and we have our upper boundary up here. I only have one triangle, so I don't have to worry about hinge theorem. Hinge theorem is when I have two triangles. Lower boundary, we will subtract. Remember when we were looking at, can this form a triangle? I have to make sure that these two smaller sides, if one of them is the biggest, that third side isn't too big. So I have 30 inches and 18 inches. So for my lower boundary, we're going to do 30 minus 18, and that gives us what? No, not 14, but close. 30 minus 18. 12. So 12 inches is my lower boundary. What do you think I do to find the upper boundary? Add. Upper boundary, 30 plus 18, we get 48 inches. Nicely done. Whenever we are looking at just one triangle and we want a double-sided inequality, that's where you subtract to find the small, add to find the big. If it's two triangles and we want to find a range for x, that's when we do the hinge theorem. Up on Canvas, the answer key for this is already posted. On today's Canvas page, if you scroll all the way down to the bottom, it says Geometry Module 6 Test Review Solutions. And if you click on that, you can see all of my work for all of the problems here. Again, that is Tuesday, 12/10, review for Module 6 test, day 2. You'll find that in the Module 6 module. All right? Reminder, you will be turning in this test review tomorrow when you come in to take your last regular test of the semester.